radius to be 3,959 miles. 3,959 miles, and it says plus or minus 1 mile. What effect would the tolerance of plus or minus 0.1 mile, 0.1 mile, have on our estimate of the Earth's surface area? All right, so if we have the surface area of a sphere is
4 pi r squared.
Thank you. So we can go ds dr equals 8 pi r. So your change in the surface area is, we can actually multiply both sides by dr. Think of it that way. And the dr represents the change in radius. The ds stands for the change in surface area. Okay, so our change in surface area would be 8 pi, our radius would be 3,959, and our tolerance, or error, would be 0.1, and that will give you the change in the surface area. Yep.
So what if you had a function where, like, adding +1 was different than minusing +1? Like, do you know what I mean?
Yeah, so the error, that's why we would usually do absolute value. It doesn't matter if the error is positive or negative.
Okay.
The error would be
Doesn't affect
bigger. No, good question.
Yep.
So if I made that negative 0.1, then it would just be, the same answer would just be negative, but that's right. So then the book tells us that it is 9,950 miles squared.
Should we trust the book?
Yeah, because I don't want to do that. Okay, so this is an estimate. The ds is an estimate, the dr is an estimate. The literal would be delta over delta, but in calculus we say that is an approximation of ds dr. Okay, so these are called differentials. A dr is a differential, ds is a differential. It's just the change in s, the change in r. Okay, we can do that, right? Find the derivative, plug in what we know. Pretty easy. It gets a little more difficult in example 11, determining the tolerance. About how accurately should we measure the radius of a sphere to calculate the surface area within 1% of its true value? Alright, so the surface area has to be within 1% of its true value. So we start with, first of all, I would not follow the way the book does this problem. I would say our change in surface area has to be within 1% of the actual surface area. I don't think the book does that anywhere, but that's the most important part of the whole problem. Okay? If you get here, the rest is kind of a process, but this is something that we have to figure out. So the error in the, or the change in surface area, the tolerance of the surface area, has to be within 1% of the actual surface area. Does that make sense looking at it anyway? Okay, so now we'll do the process. ds. We'd be given this same equation. We would do the derivative and solve for ds. We already did it. So it's absolute value 8 pi r dr. And our s is 4 pi r squared. So all I did was substitute in the ds and the s from the problem. Okay, so now we want to solve for dr. So I'm going to divide by 8 pi r. Divide by 8 pi r. So I get, alright, so the pi's cross off and r cross off. 4 over 8 is 1/2. So you see that it's 1/2 over 100 r?
That's a weird way to write that.
Right. But it asks you,
Just be 1 over 200.
yeah, so 1 over 200, that's the same thing. But what is the question? How accurately should we measure it? So that's why we write it within as a 100 on the bottom, so it has to be within
0.5%.
1/2%. be your answer.
Can you redo that entire thing? That made 0 sense.
Yeah, I'll do a different one like that. Okay, so it says how accurately do we have to measure, and our radius, or change in radius, so the error of the radius has to be within 0.5%. And if it's within 0.5%, then we know that the surface area's error is going to be within 1%. Alright, so let's do we'll do volume. So
Do problem 44.
what is 40? What is it asking you?
It's the volume is to be calculated with an error of no more than 1% of the true value
Of a sphere?
of a right circular cylinder. What? The height and radius of a right circular cylinder are equal, so the cylinder's volume is V equals pi height.
Alright, I'm not going to do that one.
Sorry.
But we'll say volume of a sphere is 4/3 pi r cubed, and I want to know how accurately do we have to measure the radius for the volume to be within, we'll say 2%.
That's how I write it.
Alright, so we're given our formula, but this first step is the most important. So see if you can figure out what we're going to write there. For dV has to be within 2% of the actual volume. Anybody have that? Okay, good. We're getting there.
Wait, why would you put V there and not R?
Because you're finding volume.
Okay.
Alright, so why don't you try this problem then?
I know what I'm supposed to do.
Okay.
It's just,
Do you need help?
I don't know why. Yeah, I'm kind of confused.
Well,
I don't know what I
wait,
did.
okay. Let's try it. Okay.
Cancel that.
Oh,
Cancel some stuff.
Is 2/3%?
Mm-hmm.
So the 4's cross off, pi's cross off, one of the r's
yeah, so it's
stays.
right. You just have
2/3
If you just
over 100.
this is correct.
So 2/3 of a percent.
So then it's 3 over 50, which is the same as 2/3 over 100, which is what it is. Does that make sense? You just
That's
like,
not all that easy. That's
this
icky
is
stuff,
right.
right?
This
Trying
is
to figure out the
these
percent with
facts,
all
you
that.
just start simplifying them away.
Okay, so the first thing you were supposed to do was find a
You should have 100 on the bottom.
Yep.
'cause it's
Then you
actually
put that into
percentage.
where V is.
Your dv and your v, yeah.
Okay, I failed to find it.
Well,
That's alright.
so
But I
it's
had the
in-
process.
It's like right. Oh, yeah. So that could be moved down there, and then so you're just left with 200.
We're finding it
And then
from
you
within.
simplify
Would you say agree?
it. Does it make sense? Okay.
It's a
Right.
proportion, not a
Good.
constant.
And they're all similar shapes, right? So if it's a big sphere, a small sphere, your answer is going to be just based on the size. So it's the percentage.
Will you ever have like will the percentage ever change by R? Like could you ever have change in dr equals like r squared or something like that? Because it makes sense what I'm asking.
Will it always be linear on the right?
Yeah.
No.
Okay.
No, because when you do it, I could ask this, but I'll just explain. So when you do a derivative, you're decreasing the degree by 1, and you're going to end up dividing by that. So you'll always have 1.
Oh, sure.
Makes
Because power.
sense. Yep.
Yeah.
Okay, so that's 4.5.